Think electronics are complicated? Not anymore! Hey there, I'm Jacob, and today we diving into the world of breadboards, the ultimate tool for DIY electronics. Stick around, because I'll show you how to use one, avoid common mistakes, and even build your first circuit in a minute. Breadboards are essential tools used in electronics, enabling engineer students and hobbyists to build and test circuits without soldering. The breadboard's design consists of a grid of holes into which electronic components and wires can be easily inserted. Do you know that the term breadboard had its roots in the early days of electronics experimentation? Originally, hobbyists and engineers used wooden boards, literally the same kind of boards used for slicing bread, to mount and connect their electronic circuits. These wooden boards served as a convenient flat surface to which components could be nailed or pinned and connect with wires. Breadboards found application in prototyping to quickly build and test circuit designs. They are invaluable for experimenting with different components and configurations before creating more permanent circuit. In education, the breadboards are widely used to teach students the basics of circuit design and electronics. They provide a hands-on way to understand how circuits work. Breadboard's utilization in testing purposes allow to test components and small sections of circuits during development. Breadboards come in various sizes. Depends on dimensions. 4 types could be listed. Full-size breadboards. These are large breadboards with plenty of space for complex circuits. Half-size breadboards. These are smaller and more compact, suitable for medium-sized projects. Mini breadboards. These are very small, ideal for simple circuits or projects with limited space. Micro breadboards. Extremely small, with fewer than 100 holes, used for very simple circuits. Here's a detailed breakdown of full-size breadboard structure. The main body of breadboard is made of plastic and contains usually 840 tiny holes named tie points, arranged in a grid pattern. The breadboard has 2 main types of areas: terminal strips and bus strips. Terminal strips are the main areas used for building circuits. A standard full-size breadboard usually has 2 terminal strips. Each terminal strip consists of 64 rows. Each row of 5 holes are electrically connected and typically labeled A to E and F to J. Okay, let's break it down. There is a tape under the breadboard. The tape is often used to secure a breadboard to a surface, preventing it from sliding around or shifting while working on a project. Let's remove it. As you can see, a terminal strip indeed has 64 rows of 5 interconnected holes on each side of central divider, totaling 128 rows across both strips. Bus strips are used for providing power and ground connections. These are generally found on the sides of the breadboard. The red line typically indicates the positive voltage rail, VCC, and the blue or sometimes black line indicates the ground, GND. Unlike the terminal strips, The holes in the power rails are connected in a long strip along the length of the breadboard, making it easy to distribute power across the breadboard. What is important? Full-size breadboards usually has 8 bus strips, usually 4 for positive voltage and 4 for ground. But you can use wires to extend the strips. In most cases it is convenient to have extended strips connected to one energy source. Personally, I had an issue with this few times and had to spend time on troubleshooting and wondering why my system hadn't worked. After all the components was correctly connected. It turned out that I used a bus strips which wasn't connected to energy source. Because of these events, I always keep a little mental reminder that says, "Hey, don't forget to put in these 2 silly wires." Please let me know in comments when you had similar stories. Let's go back to breadboard structure. Central divider is a break in the middle. Breadboards usually have a central gap separating 2 terminal strips. This gap is designed to fit dual inline package, DIP in short, of integrated circuits, with each half of the rows serving one side of integrated circuit pins. To be able to create systems, breadboard connectors are required. So-called jumper connectors are simply male-male connectors of different lengths and colors. Let's dive into the fascinating world of circuits and discover how to use breadboard to build simple circuits. First, we will design a simple electrical diagram to build an engine start system. On the beginning, we need to have a DC voltage supply. DC is a shortcut from direct current. Then we need to connect this supply to the ground and insert a switch to be able to turn off and turn on a current. Finally, we need to insert an energy receiver, which in our case is a motor. One wire of the motor have to be connected to the ground. And we have it! As DC voltage supply, 4 batteries in battery basket will be used. Every battery have 1.5 volts and are connected in a series. In a result, 6 volts is connected to the bus strip. Then we need to grab a switch and connect positive voltage bus to one of type point of terminal strip via the switch. Next we take first wire of a motor and pin to a type point in the same row. Second wire should be connected to the ground. That's exactly it. Let's test. Voila! Alright, it was a short video showing you the basics of breadboards, an essential tools in electronics, providing a simple and efficient way to prototype and test circuits without soldering. They allow for easy modifications, making them ideal for experimenting with different components and designs. Whether you're a beginner or an experienced engineer, mastering the breadboard is a key step in bringing your electronics ideas to life. If you enjoyed this video, please give the thumbs up. To see future videos like this, make sure to hit that subscribe button. If you want to see me cover any other topics in the future, leave a comment down below. Welcome to my webpage, linked below. It's currently under construction, but feel free to check back soon for updates. That's all for today. I hope you enjoyed the video, and I can't wait to see you next time. Take care and goodbye.